that we are going to be using is not in the general form. By this mean, we need to change it to the general form. The general formula is mx plus b. We need to isolate our fx by moving our 6 to the other side, changing the sign to a negative. Now that we have our fx isolate, we can change it to the other side. It's more convenient. And now we can find our slope. Our slope is going to be -1. Now that we have our slope, we can find our y-intercept. How can we find our y-intercept, you may be asking? By substituting our, here let me write again our equation. Now we just need to solve. We need to change our variables with 0, and we will be getting the y-intercept. We just need to write it in coordinates. Now that we have our y-intercept, we can get our x-intercept. How can we get our x-intercept? The same way that we got our y-intercept. But instead of changing the 0 here, we're going to be changing it in this variable. So it is going to be 0 equals to -x minus 6. We are going to be changing our x to the other side. So it's going to be a positive x, because every sign that is changing to the other side is going to be making the opposite of. So now it's going to be x equals -6. Now we just need to write it in coordinates for later to be graphed. And that's our answer. Now that we have these values, we can graph. You're gonna grab your ruler and we can graph. So our y-intercept, that is going to be 0, -6. So we need to count
1, 2, 3, 4, 5, 6.
-6. We got 0, so we're going to write right here. And our x-intercept, or is called abscissa, is on -6 with 0. So we're going to do the same process.
1, 2, 3, 4, 5, 6.
We're going to write our dot right here. So now we can do the down side technique to get to the points. So and there's our dot. And this is our graph. This is the ordinate. Let me write it right here. And this is the abscissa. And remember, students, in linear functions, the domain it's going to be negative infinite, comma, infinite, always, as well as our range, negative infinite to infinite, because we can see that this is going down, this is going to be up. Thank you.
So right now, I'm going to teach you 3 examples of functions. Let's take a closer look. Okay, so first we need to find the vertex. For the vertex, we need the formula for h. H is minus b to a. Okay, now we have the h and we need the k. Okay, so now to find the k, we need to substitute all the x's in our function into our h, that it's 2. So our vertex will be 2, 5. Don't forget to use your calculator so you get your answers right. For the x-intercept, we will use the general formula. This is how it looks with our corresponding numbers. Okay, so we place it in the calculator first with the plus sign and we check the answer. Place it with the negative sign and here we have the 2 x-intercepts. For the y-intercept, you need to replace all the x's in the function to zeros. And we need to resolve it. Okay, so let's graph. First, we're going to find the vertex. I have 2 in x, 5 in y. Here it is. The next step is finding the x-intercepts and the y-intercept. Okay, now that we have all the dots, we need to connect them. And remember that if in your function it was negative, your line will be upside down. It will go down, 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 down. Remember the arrows. So you need to remember that when you have arrows, the line is infinite and it goes on and on and on. So for the domain and range, have an imaginary line that goes touching the dots. And when you can see, it touches the infinite negative. So it will be negative infinite and it still is infinite at the other side. So it's positive infinite. For the range, is the same procedure. You need an imaginary line that it goes horizontally. You can see that this is infinite, so it's minus infinite or negative infinite, and you get to 5y. So it will be negative infinite with 5, and it's bracket because it is a. So the second problem is a radical function, so let's get it started. Okay, so we're going to solve for x. For the square root, we're going to have power like this, and it cancels both. So it will be 0, x plus 2. Okay, so it will be minus 2 for the x, and for the y, we need to find a number that is outside the root, so it will be minus 2, comma, minus 2 for the vertex. The x-intercept, you need to turn the y to 0 and solve for x. Okay, so we solve for x, we pass the negative 2, positive 2, this 2, it goes dividing, and it gives us negative 1 for the x-intercept. For the y-intercept, it's the same as the y, we search for the name outside the root, that it's negative 2. We graph following the dots and the intercepts, and we draw the line. Don't forget the arrow. For the domain and range, remember that it's the same. You need to follow an imaginary line, and it's the first dot that it touches, that it's negative 2 to infinite because we have an arrow. So it will be bracket because it is a whole number, negative 2 to infinite, and parentheses because it's an infinite. For the range, it's the same. You imagine an imaginary horizontal line, and the first dot it touches is negative 2. So it will be the same answer, negative 2, infinite, parentheses. Last problem with me, that it's the third problem, it's going to be a rational function. So the first step is to find the vertical asymptote. For that, we need to solve for x in the denominator. So we can solve for x in the denominator, so it will be 0. Okay, for the horizontal asymptote, we need to check for numbers with an x. We see here 2x and 1x, so it's 2 and 1, and it's 2 for the horizontal asymptote. For the x-intercept, we will change the y to 0 and we will solve for x. So it's dividing, so it passes multiplying. The 8 passes as negative, the 2 passes dividing, and it gives us -4. For the y-intercept, we change all the x's in our function to 0. Okay, so we placed this in the calculator and it gave us an error, so it doesn't exist our y-intercept. Okay, so now we will graph following our asymptotes and our numbers. Here we had vertical asymptote, it doesn't exist, but the horizontal was 2, so we will make a dot line here to mark our horizontal asymptote. We mark our x-intercept and we will graph. So we'll follow the line, and because it is the same on the other side, we will draw it similar. And finally, for the domain and range, we will use our ruler. We will see that it's infinite negative. We follow in the 0, it cuts, it does not connect with the other, so we use the union, and then we start again in the 0 and then again in the infinite, and it will be the same with the range. If you see, we go up, it's infinite. Okay, so my ruler changed from gray to pink, but here we see the 2, that it's the horizontal asymptote. So the range, it will be different. We will have negative infinite because it goes infinite. It's 2 union because it cuts the line, it doesn't connect. And 2 to infinite because it goes up and up. Here, don't forget to draw your arrow. And that will be all. This is your answer, this is your graph. These were the 3 problems that I'm going to teach you. Thank you very much for your attention and for seeing our channel. We will see you soon.
We got to the end. Now we can see my favorite function. That is the exponential function. Let me explain it to you. The example that we're going to be using today is real fun. Because, well, let me show you. It's plus 2. Okay. Here we need to find first our horizontal asymptote. How can we find our horizontal asymptote? You may be asking yourself. It is going to be always our C value. What's our C value? Our last value. If there's no C value, it's going to be equal as 0. Remember that. So now that we know our HA, it's equal to 2, we can continue. Now that we have our horizontal asymptote, the next step is to find our y-intercept. It's going to be the same process that I teach you in the first problem. So we write down our problem again. Let me put what we're doing, because in math it is always important to put what you're doing. We're going to be changing this value. So it is going to be fx e 0 minus 3 plus 2. Now we just solve fx with a negative cube plus 2. So now that we have this, what are we going to do? We're going to grab our calculator and let me show you how is it done. Now to solve our last equation, we just need to click Shift to make our logarithm, and we just type in the variables. Just click here, plus 2, and this is our y-intercept. We know that our y-intercept is 0,2.05. We can get our x-intercept. It is going to be the same process as in here. So we're going to be writing fx equals x minus 3 plus 2. But we're going to be changing the fx to a 0. So it's going to be 0 equals to e x3 plus 2. So now we're going to be moving our 2 to the other side. So we're going to change the sign and leaving the e with the x to 3 value. Okay, so now what do we do here? There is no such thing as a negative logarithm. No number that is negative could get a logarithm. So by this means our problem, our x-intercept does not exist. Now that we got to the last part, which is the fun part, we are going to be graphing. We're going to be graphing today. I previously drew it with my steady ruler. And now just let me recopy our variables, which are the horizontal asymptote, which is 2, that is represented 1, 2, 3, 4. That's right. So 2. The horizontal asymptote is represented with a line which is dotted or spotted. I don't know how to call it. What is like this? Let me do an example. More or less, this is like this, but you get the idea. Okay. Now that we have our horizontal asymptote, we can continue to write our, which is this horizontal asymptote, this y-intercept, sorry, I'm messing myself. So it was 0,2.05. We know that here is 2, so our dot is going to be a little upwards, so like right here. This is our y-int. Now that we put our dot, we can proceed to write, which is going to come from here all the way right from the dot, and it's never going to touch the horizontal asymptote. Never. We're missing just the domain and the range, which are, the domain is going to be always, minus negative infinite to infinite, and our range is going to be 2 to infinite with no brackets. Sorry guys, didn't mention it last time. Where did I got the 2 from? I got the 2 from our horizontal asymptote. Also, I didn't mention that the graph has an exponential growth. Well, here you have all the problem, and I would like to thank you very much for coming to our channel, and I would like you to remind you that you can always come to us by asking any help, and remember that greatness isn't defined in a grade. So thank you very much, and see you in the next time.